Dear students, having specified the production function, now we consider the investment function. The investment function. The investment function. As I told you, we assume that the economy is closed and also there is no government. Now, in per worker terms, total demand for output is equal to consumption per worker and investment per worker. That is, Y is equal to C plus I. Y by L is equal to C by L plus I by L. Output per head worker is equal to consumption per worker plus investment per worker using small letters. C by L, C plus I. Y is equal to C plus I. And Solow assumed that consumers save a fraction S of their income each year, so that savings per worker is Y minus C is equal to I, and from our assumption I is equal to S, or I is equal to Sy, that we have considered in the previous class. So I is equal to Sy from our previous discussion. Y is equal to C plus I, Y minus C is equal to Y. I is automatically invested, so I is equal to S in a closed economy. That is, investment per head is equal to savings per head. Savings per head is equal to S into Y by L. And it tells us that investment is proportional to output, with S as the fraction of output that goes to investments. Investment is proportional to output, and this S shows the fraction of investment which is converted to investment. Now, substituting this into the per worker production function, Y is equal to Fk. Y is equal to Fk. We get the investment function. We get the investment function which shows the relationship between per capita investment and per capita capital stock when investment is equal to saving. So, substituting, I is equal to S into Fk, because Y is equal to Fk, I is equal to S of k, or using the Cobb-Douglas production function, it is equal to S into, as Y Fk in the Cobb-Douglas is equal to A k raised to alpha, it becomes A k raised to alpha. I is equal to S of k, or S into A k raised to alpha. All this in per worker terms. So, given that Y is a function of k, the output, that is the aggregate per worker production function, the per worker investment function or the per worker saving function is given as S of k, or S into A k raised to alpha, is equal to A k raised to alpha in the Cobb-Douglas production function. Now, we have introduced two ingredients of the Solow model. One is the production function, the second one is the investment function. These two ingredients describe the economy at any moment in time. Per worker production function shows total output of goods and services. Investment function shows that part of the output which is invested. It also gives us the amount consumed. Now, from a given stock of capital, production function tells us how much output is produced. From the production function or from the saving function, we know how much of this output is consumed and how much is invested. Now, at any moment, capital stock is a key determinant of an economy's output. Capital stock determines capital labor ratio. So it is a key determinant of an economy's output, but we know that capital stock changes over time. And change in the capital stock causes economic growth. A given capital stock produces a given level of output, but as capital stock changes over time, the result is economic growth. And change in the capital stock is determined by two factors. One is investment, the other one is depreciation. Capital stock changes over time due to addition to, that is investment, gross investment in any given period, and also depreciation from existing stock of capital. And Solow model assumes that a constant fraction lambda of the capital stock is depreciated every year. A constant fraction lambda of the capital stock is depreciated every year. For example, if a capital stock will last for 20 years, then lambda is equal to 0.02. If a capital stock lasts for 20 years, depreciation rate is 0.02. If 0.05% will be depreciated every year, like that. And since we assume that a constant proportion of capital will be depreciated every year, we assume that depreciation per year is lambda k. Depreciation is lambda k. Depreciation per worker is lambda k. Lambda is assumed to be a constant, 0.05, 0.2, etc. If we plot lambda k against k, if we plot lambda k against k, lambda k, you will get lambda k as a straight line with the slope equal to lambda. Slope equal to lambda, constant depreciation rate. And capital accumulation is change in the capital stock per worker. We can write it as delta k is equal to k t plus 1 minus k t. Delta k, change in the capital per head, is equal to k t plus 1 minus kt. And this is equal to capital investment I minus the loss of capital in the form of depreciation, lambda k. So delta k is equal to I minus lambda k in per worker terms. That is, the change in capital per head is equal to investment per head minus depreciation per head. Delta k is equal to I minus lambda k. Okay, change in the capital stock is equal to investment minus depreciation. And this equation is the capital accumulation equation. This equation is the capital accumulation equation. And here we assume that population growth rate is 0. That is, if population or labor force is not growing, capital per head increases, and increase in the capital per head is equal to increase in investment per head minus depreciation per head. So substituting in the relationship we have discussed earlier, delta k is equal to, I was written as S of k minus lambda, and this equation is the fundamental equation in Solow growth model. Delta k is equal to S of k minus lambda k. That is, change in capital per head is equal to change in saving or investment per head minus change in depreciation per head. And using the Cobb-Douglas potential function, this can be written as S a k raised to alpha minus lambda k. S a k raised to alpha minus lambda k. And this is the fundamental equation of Solow growth model. Delta k is equal to S of k minus lambda k, or delta k is equal to I minus lambda k. Now, given the capital accumulation equation and also given the potential function, now we can define what is known as steady state. We can define steady state in the Solow. We can define steady state in the Solow model. Now, in the Solow model, steady state is defined as the level at which capital per worker comes to rest and stop changing over time. So, steady state is the point where delta k is equal to 0. That is, change in capital per head is equal to 0. That is, 0 is equal to, we write it as S of k star minus lambda k star. That is the point where S of k star is equal to lambda k star. Lambda k star. Now, using the Cobb-Douglas potential function, this can also be written as S a k star alpha is equal to lambda k star. S a k star alpha is equal to lambda k star. So, steady state is the point where K by L is a constant. Capital labor ratio neither increases nor decreases. And this is the point where depreciation per head is equal to savings or investment per head. K by L neither increases nor decreases when investment per worker or savings per worker is equal to what is known as depreciation per head, or simply investment is equal to depreciation. Now, we can show this relationship graphically by using the investment function and the depreciation line. And when the investment function and the depreciation line intersects, that is the point of the steady state. And in the figure, this is given by K star, where the depreciation line lambda k intersects the savings line or investment line S of k. So, this is what is known as the steady state. And here, if the K by L is given as K star, capital per head neither increases nor decreases. Now, this graph which depicts the steady state is known as Solow diagram. Solow diagram. This graph is known as the Solow diagram. It depicts the steady state. Now here, this Fk is the potential function, and this potential function shows for any level of k by L the corresponding output per hertz. That is something which we have considered earlier. And S of k shows the corresponding savings or investment associated with any level of k by L ratio, and lambda k is the associated depreciation per worker. And as the figure shows, there is only a single k by L at which at which the amount of investment is equal to the amount of depreciation. And if the economy is at this level of capital stock neither increases nor decreases. That is, at k star, delta k is equal to 0. Delta k is equal to 0. So that capital stock k by L, output F k are steady over time. So we call k star the steady state level of capital. We call k star the steady state level of capital. This is the point where this k by L neither increases nor decreases. This is the point where savings per worker, investment per worker is equal to depreciation per worker. And this graph itself shows Solow diagram. And in the next session, we will consider the dynamics of the Solow model. Here we have defined the steady state. K star, associated output is Y star, and this is the corresponding consumption per head, and this is investment per head. And in the next session, we will consider the dynamics of the Solow model. The dynamics of the Solow model.